Okay. All right, ready? Some word problems for your day. Really exciting stuff. Okay. How do you say that name? Azam invested a total of $60,000 in two accounts. One account pays 5.2% interest annually, and the other pays 6.2% interest annually. At the end of the year, Azam earned a total interest of $3,480. How much money did he invest in each account? So in the past, in Math 60, we would always what would we do? We would have to have one variable only. But now that we're doing systems of equations, we get to have two variables because we're going to write how many equations? Two equations. So this time you can use x and y. A lot of times in Math 60 you wanted to use x and y, but now you actually can. So what do you want x and y to stand for? What does x represent? Yeah. Because that's the question. How much money did he invest? Oh, wait, how much money did he invest, right? So invested at what percent? He has one account at 5.2%, right? And Y would be the amount invested at 6.2%. Or you could say in account number one, account number two. But it's kind of nice to put those. Now, what is one scenario, one equation that we know? So first thing we did was we defined variables. Okay. Second step is to write equations. We're going to write two equations. So we have basically two different kind of situations. How much money does he have altogether total? He has $60,000, right, that he's investing, right? So what do we, if we have two amounts that we're investing, x plus y would equal how much money? Yeah, that's our first equation. X plus y equals 60,000. Now we know something. If I take a percentage of x, the amount I invest in x, and I take the percentage, the amount of interest I earn on y, and I add them together, I get a total amount of interest, right? So 5%, 0.052, 5.2% of x plus 6.2% of y is equal to how much interest did he earn altogether? Yeah, 3,480. Does that second equation make sense? Why did I have to make those numbers into decimals?
It's percentage. Or it's not a whole number.
Yeah. The percent is the percent of a, yeah, I'm taking the percent of how much money he invested. Okay, now what would be the easiest variable to get by itself? Because we want to use the substitution method. And actually, I think you guys could do it from here on out because it's really just a matter of, solving for one to put it into the other. But let's do it together just for recap. So how do I do the substitution method, and what variable is the easiest to isolate in which equation? Well, I personally don't really want to divide by this, yeah? I have a coefficient of 1 here, and I have a coefficient of 1 here. So either way, I could subtract y and get x by itself. That would be, for me, the easiest. If I can identify that the coefficient is only 1, then I don't have to divide, right? So it's kind of like, this is exactly what happens if you say y equals 60,000 minus x. That would have been what you had started out with in Math 60. You would have said, okay, the first account has a certain amount in it. Then if I take away that amount from 60,000, that's what I have left to invest in the other account, in account number 2, right? Okay, so all I did was subtract x from both sides to get y by itself. Are you seeing that difference there? Okay. And now we want to do the substitution. So I have y by itself, so I'm going to substitute all of this in for y. You get that? So this is step 3, is I'm going to solve. So I have 0. And remember, you have to plug the first equation into the second. Somebody already realized if you put the first equation into the first, then you get all real numbers because, you know, they're the same line. Does that even make sense what I'm saying? Anyway, you'll go back. You'll review. But I have to put the first equation into the second. Okay? 0.52x plus 0.062, 60,000 minus x equals 3,480. Okay, so we're solving now. And this is like the tediousness of solving, but I have to distribute here, right? For this, I will use a calculator. This is not really fun mental math, personally. Oops, that arrow went pretty far. So, 60,000. And by the way, if I took 60,000 and I invested it at 0.62%, I would have made interest of 3,720. That's way more interest than I earned, isn't it? So that means I didn't put all of that in the higher interest account because it was more risky, wasn't it? So here we have 0.052x plus 3,720 minus, what's the coefficient of x now? Well, if I distribute is what I meant. You see? Okay. Now what should I do to get x by itself? What's that? Combine like terms. Exactly. So what's the difference in the interests, right? If I subtract them, do it on your calculator then. Negative 0.1x. And I'm going to subtract this from both sides. Can I do that on the same line? Everyone's following me. Minus 3,480 negative 240, right? What do I do now to solve for x? Divide, right? X equals, yeah, because it just moved the decimal place over. It should be 24,000. Is that what you got? So 24,000 is invested in one account. How much money do you have to invest in the other account? So 24,000. This is going to be our check, okay? I'm going to solve for y first, equals 60,000. I want to find out how much I have left. If I deposit into one account, I want to be able to have money left for my other account. So 36,000, I love it. 36,000, thank you for being my human calculator. Now let's check that and make sure that works. If I invest a certain amount, 24,000 at 5.2%, I'm going to have the interest is 5.2% of 24,000 plus 0.62, 6.2% of 36,000. How much interest is that? That's supposed to give me a total interest of 3,480, right? Let's see if it does. So on my calculator, I'm going to type in 0.025, that's 5.2%, times 24,000. That gives me interest of 1,248. 0.062 times 36,000 gives me interest of 2,232. Add those two numbers together, and yes, isn't it great when it comes out? 3,480. So that worked out. 3,480 equals 3,480. So that means our sentence answer, the final step is going to be, you did all this work. Now claim it. Azam invested $24K in 5.2%, $36K in 6.2%. And you will flower it up. Flower up your answer so it's like better. It sounds better than mine does. Word problems. You're going to want to read the textbook, right? Read the textbook. Really take your time with the textbook. They're starting to embed some videos in the textbook as well. So you might see some videos on this besides mine. You can also go, I have that whole entire section of chapter, it was called chapter 4 in the previous book, but those other videos that I uploaded to, okay. Remember that you can always come to office hours too. Let's go on to the next one. We're going to do one more together, okay? And if you don't get it completely done, you can go back and watch this, okay? Let's look at number 7. So there's this guy. He's a chemist or a lady. Let's call her a lady chemist. I don't know why. And she has a beaker full of solution, okay? 12% alcohol solution. And she has another beaker of 8% alcohol solution. She wants a total of 1,000 grams and of the solution to have a concentration of 12, or sorry, where am I getting the 12s there? 9.2%. Yes, 9.2%. Thank you. How many grams of the 12% solution? So essentially I have some solution here that I'm going to pour in here. This is my 12%. And then I have some more solution over here that is my 8%. Basically, you're making a cocktail, aren't you? You're mixing drinks. Because that's the reason why, if you drink straight tequila, it has a lot of alcohol in it. But if you put it in a margarita, your alcohol concentration goes down. That's the same thing that's going on here in the chemistry lab. They're mixing a bunch of different alcohols together. Okay? They have one that's really strong. This is our X, and they have one that's really a little bit weaker. So if you mix the strong one with the weak one, you'll get something in between, right? Halfway, not really halfway in between. Okay, so X, we're defining the variable. What does X stand for and what does Y stand for? Let's be as specific as we possibly can. It's the variables that we define are going to answer our questions. X is what are we finding? How many grams? So it's the grams of 12% solution. What does Y stand for? Grams of 8% solution. Okay, now what? What should I do next? I've defined the variables. I should write equations. Equation number 1, equation number 2. So number 1 can describe, you have an equation that describes how much solution do you have altogether. You're going to pour it in. Are you just going to pour in like all kinds of amounts? You're going to pour in enough so you get exactly how many grams? 1,000 grams. So however many grams of X plus however many grams of Y is going to give us a total of 1,000 grams total. This is all to do with the mass or the weight, right? Grams? I don't know. I'm not a chemist. Okay. Tell me, you chemistry majors. Now I'm taking 8%, 0.08 of X is going to tell me how much alcohol is in that solution. Yeah? Oh, I did. Okay, sorry. 0.12x, that's the 12%. And 8% of the alcohol in Y is going to give us is it just going to give us 9%? 9% of what? Yeah, because I might have, 500 grams of this, 500 grams of that. It's not all alcohol. It's only 8% alcohol. 8% of this is alcohol. 12% of however many grams I put in is alcohol. 9.2% of 1,000. That's the tricky part. The other one you didn't have to put of the percent of the total because that was the interest, right? It was already calculated for you. So does everybody understand why we have to take 9%? The second equation tells us, so right here, this tells us the total grams, and this tells us the total alcohol. Because we have two things going on. We have two different mixtures. If we only had the first equation, we could have an infinite number of amounts of liquids. You know what I mean? Like I could put 1 gram but that's not going to give me the right concentration. So the second equation that is a little bit more complicated because it deals with those percentages is going to tell me the concentration of each. And that's why we get that sweet spot, right? Because I can't just put 500 and 500 because halfway in between 8 and 12 is 10. That's going to be too strong. You see what I'm saying? So now, how could we solve it? What should we do to solve it? Yeah, so let's get y by itself. Y equals 1,000 minus x. He will do that substitution, okay? 12% of x plus 8% of 1,000 minus x equals, and you can actually multiply that out to a number. 9.02 times 1,000. 92. Does that make sense, those numbers there? They make more sense now? Okay, now, if I had 8% of 1,000, let's say I did all my 1,000 grams, the 8% alcohol, how much alcohol would there be? 0.08 times 1,000. 80. So x plus 80. Does everybody see where I got the 80 from? Just using the distributive property, right? Distributing again here. Minus 0.08x equals 92. What should I do to solve next? Yeah, I can subtract 80 from both sides. Could I combine my like terms? What's the difference between 12% and 8%? 4% equals 12. Okay. How do I get x by itself? X equals 12 divided by 0.04 equals 300. So that means we have 300 of the 12% solution, and it kind of makes sense that we would have to have more of the 8% to bring it down below halfway, right? So 300 grams of 12% solution, and how many grams would be left for the 8% solution? 700. 700 grams of the 8% solution. And that's basically equation 1. That's pretty much a check right there for equation 1. Now I want to check of the second equation. So you see how even though I didn't plug in 300 plus 700 equals 1,000, I'm still checking it mentally. I mean, you can write that down. 300 plus, it's probably best to write it down, equals 1,000. Okay, that's the first check. For the second check, I have to do a lot more math. I have to take 12% of 300, and I have to take 8% of 700, and I have to see, does it give me 92? And does everybody know where we got that 92 from? So 300 times 0.12, 12%, that's 36. 700 times 0.08 equals 56. And is 56 plus 36 equal to 92? I should do some problems where I get the answer wrong so you can see what it looks like when we get it wrong. But anyway, the last page, I think, is a group work problem. So you can do that one. That one is going to be due at the beginning